Okay, so what we're going to look at today is binary addition. So first off, we want to ask, like, what is binary? So binary is zeros and ones. And in this course, you need to know this is one of the number systems you need to know. And in this case, the binary is base 2. And the idea is that, for example, decimal, which is base 10, the reason in decimal you have 10 or base 10 is because you have 10 possible states for a digit to be, which is 0 to 9. In binary, you have 2 states, which is 0 to 1. So binary is zeros and ones. Binary is also the lowest level you can get in a computer system. So if you strip away all abstraction, you end up with binary. And the reason, so it's like the fundamental kind of language of a computer. Now, the reason why it's the fundamental language or the machine language is because it has to kind of, it maps to the hardware. So the basic unit of a computer in the hardware is a transistor, which is essentially a switch that is either off or on. So what I mean is that on a fundamental level, there's either electric current going through this wire, or there is not, because the switch is open. So if the switch is open, there's no current going through the wire. And if the switch is closed, there's current going through the wire. And we represent that as either a 0 or a 1. So that's kind of the basic idea. Now, we'll also get into the idea of logic gates in another video, which is a more complex, an evolution using combinations of transistors to build Boolean logic. But in this video, we're just going to start with binary and binary addition. So binary addition is pretty simple. The idea is you have 2 numbers that you want to add in binary. And the basic idea is, it's fairly straightforward. If you have 2 numbers like this, you just add the digits together in one column. So 0 and the 1 becomes 1, 1 and the 0 becomes 1, 0 and the 1 become 1. So in this case, 0, 1, 0 plus 1, 0, 1 equals 1, 1, 1. Now, in this course, it is usually in an exam situation, you just want to do this quickly and then leave it. But if you have time up your sleeve, you can do what I call the sanity check, right? And the idea of the sanity check is to basically make sure that it actually makes sense. And the way you do that is you convert it back to decimal. So in this scenario, there are many ways to convert between decimal and binary. The easiest way is to essentially write the base, and the base, which is the 2, the power of 2, and the exponent of this base is going to be numbered from 0 to whatever, from right to left. So 2 to the 0 would be here, 2 to the 1 would be here, 2 to the 2 would be here. And the basic idea is, if you want to convert a binary number, is that you take it and you multiply it by this base with the exponent at the top. So for example, for the top number here, you would be 0 times 2 to the 0 plus the next column, which would be 1 times 2 to the 1. So see how it's 2 to the 1 here, 2 to the 0 here, plus the last one, which is 0 times 2 to the 2, which is this last column here. So if we add all those together, we would get the decimal, which in this case is simply the middle one, because 0 times anything is 0. So 1 times 2 to the 1, which is just 2. So this would be 2. So if we do the same for here, it would be, we can just safely ignore the 0. So it'd be 1 times 2 to the 0 up here, and then the plus 1 times 2 to the 2, right? So 2 to the 0, anything with an exponent of 0 is just 0, it's just 1. And we add it to 2 to the 2, which is 4. So in this case, it would be 1 times 2 to the 0, so 1 times 1 plus 1 times 4, which is 5, right? So in this case, it would be 2 plus 5, so the answer should be 7. Now we check down here, so this would be 2 to the 0 plus 2 to the 1 plus 2 to the 2, which is 7, which is 1 plus 2 plus 4. So 4 plus 2 is 6, plus 1 is 7. Okay, so that's how you convert, and that's also how you're going to sanity check any other binary arithmetic you do, especially addition. Okay, so let's jump to a more complicated addition. So let's say you had this, right? Now, 1 plus 1 is obvious. Well, actually, it's not obvious. So when you have 1 and 1, you get 2, right? But you can't write 2 because we're dealing with binary. So what do? Now, the way you handle this is basically overflowing to the next column. So you add the 2 ones, and you basically write a 0 here, and you carry a 1 to the next column, right? So you're carrying an extra 1. Now, you're probably wondering, why are you carrying only a single 1 and not 2 ones? Now, how this works is that basically when you carry over to another column, that extra column is 2 ones, right? This represents 2 ones because you're in the next column, right? So you're not in the 2 to the 0 column, you're in the 2 to the 1 column now, right? So essentially, to represent that, you'd have a single 1, not 2 ones. But if I was to bring this 1 back to the 2 to the 0th column, you'd have 2 ones, right? And the idea is 2 to the 1 times 1 is 2, and 1 times 2 to the 0 plus 1 times 2 to the 0 is also 2. So that's why you lose a 1, so to speak, because you're carrying it over to the next column. Right. So, all right, so carry this 1, okay? So that's fine. So now we have 3 1, right? So if we were to ignore these 2 1s, right, and we would just have 2 zeros just for the sake of argument, and we had this carry 1, basically that just turns into a 1, and we'd write 1 down here. So we're fine. But we have these extra 1s plus a carry, right? So now it's like, well, what do you do, right? So the solution to this problem in terms of binary addition is to, whenever you have an odd number of 1s, is to always write a 1 below, right? And that eliminates one of the 1s. So let's say we eliminate this top 1. And then you do the calculation as normal with the leftover 1s, because you have an even number of 1s. So in this case, 1 and 1, once again, all we have to do is carry an extra 1 to the next column. So once again, we have 3 1s, so write a 1 here, carry a 1. This would be a 0 and a 0, so then we're left with 1. Okay, so 1 1 1 plus 1 1 1 would be 1 1 1 0. So let's sanity check this. What is 1 1 1 in decimal? If you remember from the previous slide, it is 7. So it'd be 7 plus 7, which should be 14. So we sanity check this. So this would be 2 to the 1, 2 to the 2, 2 to the 3, which is 8, plus 4 plus 1, plus 2, sorry, which is 14. So we're all good there. Now, the final trick with binary addition is you might get a scenario which is 4 1s, right? And you add them all together. The question is, what do you do? Well, once again, we follow the rule. There's an even number of 1s, so we do not need to write a 1 at the bottom, so we write a 0. And when we carry, what ends up happening is we carry it over, and we're actually given the 2 1s, right? So we have 4 1s, and then essentially you halve it and you're left with 2 1s when you carry it to the next column. Now, when you write this, we'll write zeros here. And when you write this, you can literally just write 2 1s if that's more convenient to you. or you can just say 2, which represents 2 ones. It's up to you. Probably the simpler way is just to write 2 ones, and then you execute the next addition on the next column as normal. So it'd be 1, 1, which would be 0, then you carry a 1, and then you're left as 1. So 4 ones would be represented by a 4, which is obvious. So that's binary addition. There's no other real tricks.